your sources. You know, you'll get very different figures from different people, so don't treat these as gospel. But the capital cost it's much higher for biomass boilers and for ground source heat pumps. They're the big ticket items. If you're spending money, you're having an environmental impact, you're consuming resources. If you're just naturally tight like me, you're pretty eco-friendly. I don't leave the house unless I'm absolutely forced to. I sit in my study by my wood-burning stove and I play the grumpy old man that I don't go out. You wouldn't believe how much complexity internationally I can get into with the policy work that I do without leaving the comfort of my study, my underground study in Somerset. It's about lifestyle as well as it is about your choices. But all the wood that I burn in my stove is waste wood. I'm not even growing anything for it. If a tree comes down and somewhere in the village, I'm round there like a shot with a chainsaw on a trailer because I'm tight. And that is a good guide to sustainability.
Correct. But if everybody did that, there'd be a bit of a challenge because you'd all have to fight out.
We'd be fighting with chainsaws and that could be messy.
I think a lot of these figures, from what I understand, they came from the Energy Saving Trust, and a lot of context has to be put into figures. If we take solar hot water panels at the bottom, the £4,000 to £5,000 to install is too high because you should already have a cylinder, you should already have distribution.
A lot of these guys are going to be building from scratch,
correct,
self-building, so you're going to be putting in a cylinder anyway, because these days you've probably got more than one shower in the house. It could easily happen. You've got two hot water faucets open at the same time and you don't want to frazzle in the shower or go cold. So if you're putting in a cylinder anyway, stick in the extra coil, pipe it up to the roof, put a solar water. Have we finished? Have we run out of time?
No, not yet.
Okay.
Alternatively, if you put it in, then on a bigger house, we have put in solar hot water cylinders with a pre-feed, so it doesn't actually have two coils. You have a second cylinder that just continually gets colder.
Yep.
So during the winter months, we can even lift that to maybe 20 degrees, and that's 20 degrees that you're
still doing a bit of work.
Yeah, still doing a bit of work. So you've got to, with a lot of these things, you can't just put them in and forget. You've got to try and allow it to increase its fraction that it's going to achieve.
I suppose another reason I'm a bit keener on solar water heating than PV is it's actually manufactured in this country. And to me, sustainability is about more than energy use. It's about water efficiency, it's about drainage, it's about loads of important material considerations, what we build with. But it's also about community regeneration, it's also about local employment. And if we're sticking PV on the roof, we're sending a lot of money to the Chinese and the Germans, and they've got enough of our money going their way at the moment. If we can do more for local employment, local jobs.
I think if the feed-in tariff goes the way we think it's going to go and you get an export, you'll see a lot more solar thermal arriving.
That'd be interesting.
It will suddenly make sense. Because we're not exporting anymore.
Yeah.
Exporting the money. So yeah, let's export the electricity and use solar thermal appropriately.
Should we take some questions?
I think we should take some questions. Anybody got questions?
We'll take mine.
Hi, if I haven't got gas, what's the next most cost effective? Because I'm rural, out in the sticks. Existing build, with solar panels already, and an old boiler, 100 years old.
Nigel, you've got one on that?
Okay. You've basically got a simple choice between three sources of heat. LPG, which is still a fossil fuel, electricity, which is still a fossil fuel, and you feed it into a heat pump so you make it more like gas in terms of its emissions, or biomass, which is effectively carbon neutral. All three are going to be roughly the same in terms of running costs. Your cheapest to put in is probably the LPG boiler. We don't want you on oil. Oil is more noxious, I think, in its emissions. It's a faster diminishing resource, I think, than any form of gas. But the capital costs are going to vary, and I think biomass and heat pumps are probably quite similar.
Heat pumps will struggle on an older building anyway, because you need slightly higher temperatures.
Yes.
On an older building, depending what it was built out of, if it happened to have been copper, you're in luck because you can dry cop out quite well to get it insulated, but I'm taking yours as a stone building of some sort, and it becomes harder to treat. I would still be looking at the heat loss on it and the size of the building, because if you connect an air source heat pump into it as what's known as a hybrid or bivalent system connected to existing oil or LPG, then we would run the heat pump at 45 degrees and see how far into the heating season it would actually go on a calculation. At the moment you need a higher flow temp, it switches over to the LPG or the oil to lift the temperature. So your first 45 degrees is always done by the heat pump. And we just have an app or a smart handover. And many heat pump manufacturers now have what is referred to as bivalent ready or hybrid ready controllers, so that you can put a second heat generator into it and control it either on price, on ambient temperature, or on a time or a handover point that you choose. What you really need to be able to do though is put in the cost of electricity and the cost of the other fuel and the efficiency of the heat pump into that scenario. And then it can work quite well, handing over between the two. But if you're building a new house, and it's a very big one, and you try to put in a bivalent system, you're buying two systems. On an existing property, you've probably already got one of them, and maybe the other one will take care of 60% of the load.
I think that's very fair. I think with new, it's much easier to build in a low temperature distribution system, such as underfloor heating. Many old buildings you can't do that with, and they also need hot heat, and a biomass boiler is much more efficient at providing hot heat than a heat pump, because it has to do more work to take you up to the higher temperature.
Good old bivalent.
Yes.
Any other questions at all?
A new build house and got a gas boiler in the tank. What's the benefit of underfloor versus radiator?
I would say it's purely a matter of personal choice. I like underfloor because it puts the heat where you want it, gets rid of radiators on the walls and drying out lovely old bits of oak furniture which you might have to own. And it enables a low temperature distribution system. Heats up and cools down more slowly. It provides a different kind of heat from radiators. It's not anything like as good for drying your clothes, but we don't want you drying your clothes on the radiators anyway, because that puts too much moisture into the house.
The question was, would you mix radiators and underfloor heating? I'd mix them. Even if they're on the same floor, I'd still mix them. I have no problem with mixing them whatsoever. With underfloor heating, it's always about it's personal. Do you want to free up the space? Do you want something that's slow to react? We're doing an extension. The extension will have underfloor heating in because the extension is highly efficient. But in an area where I feel that the house could cool down significantly in 3 hours, I would not put in underfloor heating because it would be wasteful. I want a more reactive emitter, so I would stick to radiators. We're changing to aluminium type radiators, which are more convectors, because radiator is the wrong word for them. They don't radiate anymore, they convect. So you want an aluminium type that has a much larger surface area where it's been cast. You actually feel the heat far more by standing a foot away from it than you do by touching it. So start looking at convector style radiators to get the temperature out into the room, be more reactive. But underfloor heating will work very, very well. It's personal, ultimately. If you like underfloor heating, put it in. If you don't like it, if you want thick Axminster carpets, then you've got a challenge on your hands because the heat won't come out.
There's a lady here with a question.
So mine's a new build in a rural area. Is it worth the cost of, so we don't have gas at the moment, so we have to install costs through a main road, down a lane, so it would be a considerable cost. And last week they were potentially saying new homes wouldn't connect to the grid from 2025. Is it worth us thinking about connecting, or should we be looking at an alternative for our new build?
The government. What we need to stop doing is using gas to make electricity. gas is a wonderful fuel for heating. It's weightless to move. We've got a great distribution system already in place. But wasting it to create electricity, we need to use the big lumpy stuff to do that with. Be that offshore wind, be that nuclear, be that tidal. There's nothing wrong with using gas for heating individual properties. You've got to do the math, you've got to work out how much it's going to cost you to get across there. If it's prohibitive, and if it's an extra 15 grand to get there, and it's going to cost you 15 to put in a ground source heat pump, depending on the size of your house, sometimes you need to go up to 3-phase for a heat pump. If you've got to put a big heat pump in, you might have to have an additional cost there. So do the math, look at the big picture, and come up with your answer that way.
That article and those releases that have come out about gas not being able to be used in houses from 2025, on a gas hub I can see that being an issue because of the airtightness on new builds. I don't see that happening with gas boilers that are room sealed, and what will happen is that the gas in the grid will become low carbon and therefore we don't need to get rid of it.
How's the gas in the grid going to get low carbon?
By changing it into hydrogen. In the 1960s, the gas grid was pretty much hydrogen. It was known as town gas. It's now called natural gas because it's a methane base. And we're already seeing in Leeds a big test area being tested to see what happens if we put higher degrees of hydrogen into the grid. As consumers, you won't know the difference. Our boilers can already take around 19% hydrogen without changing a single thing. And when we get more and more and more hydrogen, as you manufacture hydrogen from natural gas, we sequestrate the carbon straight away. It goes back into the ground. It was in the ground, it's going back in the ground. And we're just burning hydrogen, which gives us water and heat. But therefore, by 2050, we'll start seeing by 2025 that hydrogen is becoming more intensive in the gas grid, but by 2050 it'll be a high percentage hydrogen. And we'll also have hydrogen fuel cells for cars, and we won't be worrying about electric grids. The Committee for Climate Change are very, very, very electric grid focused. And that's why they stir the pot saying, we're calling for the banning, it's not going to happen. But they're calling for it. They call for a lot of things.
They do. I didn't know where we were going to stop.
We've got to stop very shortly. Is there one last question, Animal?
On that basis, we're going to say
Fantastic.
thank you very much.